You're hungry, you're tired, and you need food now. You look at your counter and you see two boxes. One is the microwave, the old reliable. The other is the air fryer, the trendy newcomer that everyone swears changed their life. On the surface, they both solve the same problem. They make cold things hot, fast. But under the hood, these two machines are fighting two completely different wars against the laws of physics. One uses invisible light to vibrate your food into a frenzy. The other uses a miniature hurricane to blast the moisture off the surface. Today, we are going to dive deep into the thermodynamics of the air fryer versus the microwave. We're going to talk about why one makes your pizza rubbery and the other makes it crunchy, why your electricity bill cares which one you pick, and the secret hidden physics that dictates which one is actually healthier. By the end of this, you'll stop thinking of them as heaters and start seeing them as energy precision tools. Let's start with the one we all take for granted, the microwave. As we discussed before, the microwave doesn't use heat in the traditional sense. It uses dielectric heating. Inside that box is a magnetron. It's essentially a vacuum tube that converts electricity into electromagnetic waves, microwaves. These waves bounce off the metal walls like a pinball, passing right through your glass plate and into your food. Now, remember, water is a polar molecule. It has a positive side and a negative side, like a little magnet. When those microwaves hit the water, they flick the magnetic field billions of times per second. The water molecule tries to keep up, spinning around frantically. This creates molecular friction. The food isn't being heated by the air. It is heating itself from the inside out by vibrating its own water content. Microwave is the ultimate efficiency king. Because the waves ignore the air and go straight for the water, almost 100% of the energy goes into the food. It's why you can boil a cup of water in 60 seconds. But this water-first approach is why microwaves ruin texture. Since the microwave targets water, it turns that water into steam instantly. That steam wants to escape. It pushes out from the center of your bread or your chicken, turning the surface into a soggy, damp mess. Furthermore, microwaves bounce around in patterns called standing waves. This creates hot spots and dead zones. This is why your burrito is lava on the left and frozen on the right. The turntable tries to fix this, but it's an imperfect solution to a physics problem. Here is a secret most people don't know. When you set your microwave to 50% power to gently melt butter, you think the microwave is sending out gentle waves, right? Wrong. Most microwaves use something called pulse width modulation, PWM. The magnetron only has two settings, on 100% chaos and off 0. When you select 50% power, the microwave blasts your butter with 100% nuclear heat for 5 seconds, then shuts off completely for 5 seconds. Blast, stop, blast, stop. That stop period allows the heat to conduct from the hot spots to the cold spots. That is why butter explodes in a cheap microwave. It got hit with full power before it could melt. Pro tip: if you are buying a microwave, look for inverter technology. These rare models can actually output constant, low-level power. They are the only ones that can actually melt chocolate without burning it. Now, let's look at the air fryer. First of all, let's be honest, an air fryer is a lie. It doesn't fry anything. There is no vat of oil. It is actually a high-intensity convection oven. In a normal oven, you have a big space and a small heating element. The air moves slowly. In an air fryer, you have a tiny space, a massive heating element, and a fan that is moving at terminal velocity. This creates a phenomenon called the boundary layer effect. When food sits in still air, a thin layer of cool, moist air clings to the surface like an invisible blanket. This layer acts like an insulator, slowing down the cooking. The air fryer's fan is so powerful that it literally rips that boundary layer away. It replaces it with fresh, 400-degree air every single millisecond. This is convection on steroids. Because the air is moving so fast and the chamber is so small, it mimics the heat transfer rate of oil. This is why it fries. It's hitting the surface of your food with so much energy that it triggers the Maillard reaction almost instantly. The air fryer is the king of reheating. It takes that soggy leftover pizza, blasts the moisture off the crust, remelts the cheese, and gives you back the crunch. It does what a microwave can never do. It manages the surface of the food. But there is a specific way to break the physics of an air fryer, and 90% of you are doing it. Crowding the basket. Remember, the air fryer works by circulating high-velocity air around the food. If you stack chicken wings on top of each other, or fill the basket to the brim with fries, you have physically blocked the airflow. the air can't hit the surface of the food in the middle of the pile. What happens then? The moisture from the bottom layer rises up and gets trapped by the top layer. Congratulations! You've just turned your 200 air fryer into a really bad steamer. To get the crunch, the air needs a path. If you can't see the bottom of the basket through the food, you are cooking it wrong. Physics demands space. This brings us to the one area where the air fryer completely fails against the physics of real life. Volume. The air fryer works because the chamber is small. Small chamber equals less air to heat, which equals faster velocity. But that physics advantage is a practical nightmare if you have a family. If you try to cook 4 steaks in a standard air fryer, they won't fit flat. You have to do 2 batches. Batch 1, 15 minutes. Batch 2, 15 minutes. Total time, 30 minutes. By the time batch 2 is done, batch 1 is cold and rubbery. In a conventional oven, the volume is massive. You can cook 4, 8, or 12 steaks simultaneously. The heat-up time is slower, but the total throughput is much higher. The physics rule is simple. Air fryer, high velocity, low volume. Best for 1 or 2 people. Oven, low velocity, high volume. Best for families. Microwave volume doesn't matter as much because the waves penetrate the food regardless of the container size. Let's talk about your wallet. People think the air fryer is fast. Compared to a giant oven. Yes, compared to a microwave. Not even close. A microwave uses about 1,000 watts. An air fryer uses about 1,500 to 1,800 watts. But here's the kicker. A microwave can heat a bowl of soup in 2 minutes. An air fryer would take 10 minutes just to get the bowl warm, and it would probably blow the soup all over the place. If you are just warming things up, the microwave is significantly cheaper and faster. However, if you are cooking from raw, like a piece of salmon or some Brussels sprouts, the air fryer wins on quality. It's more expensive to run than a microwave, but it's much cheaper than heating up your entire 30-inch kitchen oven just to cook 6 nuggets. This is where the hidden physics comes in. There is a myth that microwaves kill nutrients or radiate your food. That is scientifically false. In fact, because microwaves cook so fast and use so little water, they actually preserve more vitamins than almost any other method. When you boil broccoli, the vitamins leak into the water. In a microwave, they stay in the stock. The air fryer is marketed as healthy because it uses less oil than deep frying. And that's true. But there is a dark side to all that delicious browning. It's called the Maillard reaction. And while it tastes great, it has a byproduct, acrylamide. Acrylamide is a chemical compound that naturally forms when starchy foods, like potatoes, bread, or root vegetables, are cooked at temperatures above 250 degrees Fahrenheit or 140 degrees Celsius. It happens when the sugars and an amino acid called asparagine react together under high heat. Basically, the darker the toast, the more acrylamide is in it. Why does this matter? Acrylamide is classified as a probable human carcinogen. In massive doses, it has been linked to cancer in lab animals. Now, you'd have to eat a mountain of burnt toast to match those lab conditions. But the consensus from health agencies is simple. Don't burn your carbs. The physics fix. Because the air fryer is so efficient at browning, it's very easy to accidentally push your food from golden brown, safe to dark brown, high acrylamide, in just 60 seconds. The rule: aim for a golden yellow color. If your fries look like dark mahogany, you've gone too far. The hack: soaking your potatoes in water for 15 minutes before air frying reduces the starch levels, which significantly lowers acrylamide formation. That's a chemistry hack for your kitchen. So, ironically, the microwave, which doesn't brown food, produces almost zero acrylamide. The air fryer is better for your heart, less oil, but you have to watch the timer to keep it safe for your cells. We also need to talk about what you put in the machine. Microwaves, you know not to put metal in. But do you know why? The microwaves push electrons around the metal surface. If the metal has a sharp edge, like a forked tine or foil, electrons bunch up at the tip until they jump through the air to the nearest conductor. That's a spark. That's plasma. That's a fire. Air fryers, the danger here is subtle. Most air fryer baskets are coated in non-stick Teflon. When you crank that fryer to 400 degrees Celsius and scrub it with abrasive sponges, that coating flakes off. Physics rule: don't use metal tongs in your air fryer. Use silicone. Once that coating is scratched, you are seasoning your fries with microplastics. So, which one belongs on your counter? Choose the microwave if you are a reheater. You eat a lot of soups, stews, rice, and coffee. You are a parent who needs a bottle or a bowl of oatmeal ready in 30 seconds. You care about maximum energy efficiency and nutrient preservation in greens. Choose the air fryer if you hate soggy. If texture is more important to you than speed, the air fryer is your god. You eat a lot of frozen snacks, proteins, chicken fish, or roasted veggies. You want the flavor of fried food without the guilt of the oil. The pro tip: the real physics masters use both. If you have a thick piece of frozen leftover lasagna or a dense samosa that's gone cold, don't put it in the air fryer for 20 minutes. The outside will burn before the middle thaws. And don't put it in the microwave for 10 minutes. It'll be a puddle. Put it in the microwave for 2 minutes to vibrate the internal water molecules and thaw the center. Then, move it to the air fryer for 3 minutes to crisp up the top and dry out the edges. That's called sequential thermodynamics, and it's how you win at cooking. Final thought: at the end of the day, your kitchen is a laboratory. The microwave is your high-speed particle accelerator, and the air fryer is your wind tunnel. Stop asking which one is better, and start asking what your food needs. Does it need to vibrate, or does it need to blow away? Once you master the physics, you master the meal.